First of all, I'll start with the short overview and introduction in the project because the topic is related with the existing project. And the main function of the application is for the controlling the electronic heating systems in the home. And the application communicates through the Bluetooth Low Energy with the devices based on the microcontrollers controllers from the Silicon Labs. The Bluetooth Low Energy, in contrast of the classic Bluetooth, is more power efficient and used in the small battery-based devices. The project is under development for almost a year and a half. The implementation of the Android application is standard with the MVVM architecture. Also in the application we are using the flows, coroutines, etc. Also in the application we have the network module with the RESTful APIs. The network module is used with the two endpoints. First is for the dynamically fetching the translation strings, and another one is for the fetching the file from the server. And I mentioned this just to emphasize that the application is queue dependent on the physical communication on the physical device and the Bluetooth communication. Also in the application, the communication between the device and the application is through the protocols. Actually, we are forming the requests on the Android through the protocols, and in our case, we are using the DENCORD protocol. It's an internal protocol, it's not for the public use. And for that protocol, is specifically that it's written in the C++, and through the Java native interfaces, we're able to use in the Android. On this slide, I have one of those requests. Actually, is the set requests. Here is an example of the Java native interface method, and also for with the wrappers we have the easier usage in the Android actually. And here is the on the right side is the wrapper for that method. Actually, is for the same purpose. The initial plan of the application was to for the project for the Android application was to work on the UI and UX for 2 or 3 months, and after that, as well as the basic communication, as connecting, disconnecting, and setting the characteristics in the project, the GATS communication also. And but due to the several reasons, such as chip shortage, the hardware for us was unavailable. And in that case, maybe best approach is using the virtual devices and mock data. But in our case, if there are resources actually for the virtual devices. But in our case, we have one feature called demo mode. In that mode, actually, we are not getting the information from the physical device. We are getting the information from the local database. Sorry. This mode is used just first. The function of this mode was for the confirming the UI and UX of the application, but after that for testing some of the features actually in the application. As I mentioned, the hardware for us was unavailable, and here we have some challenges during the development process actually. One of the biggest challenges for us was the working on the DENCORD commands, as well as the preparing the parsers before the hardware is available, because with the hardware from the hardware we are getting just byte arrays, and that information needs to be translated in the usable data. Also some of the features like over-the-air transfer, and in that moment the collaboration and communication with the other teams, the different teams, is very important. On the next slide, on the right side, I have one example for the DENCORD command actually. This is the command for the setting the actual time on the device, and here on in that command we have the Endpoint, it's actually the endpoint from the physical device. We have the parameter. The parameter is unique. It's defined from the firmware team. And also we have the parameter type. And through the helper, we are sending to Dunkor protocol. And actually, with this function, we are forming the request, custom request for the device. On the right side, I have one example with the one hexadecimal string, and it's the screenshot from the documentation. And here I want to emphasize that the communication with the other teams is mandatory, because for us it's not available to create the parsers. Actually, it's the documentation for creating the parsers without any documentation, because if we are getting the data as byte arrays from the device, we need to translate that and convert in the usable data, actually. For some of the features in the application, it was impossible for us to create it without any hardware. For example, for the over-the-air transfer, the idea behind the over-the-air transfer is actually on the Android application, we are getting the file from the server if there is update, and that file is sent to the device in the chunks of data, actually. And for that purpose, we use the RTS Solo device. It's a portable device with the simple functions as connecting, disconnecting, and receiving the file. But for that purpose also, here I want to some of the functionalities are not predictable for us. For example, the scan response functionality without documentation, as I mentioned before, it's impossible to achieve on Android side, because here on the right side I have just 2 bytes, but that bytes translated in the bits have the meaning for us, actually. Previously, I mentioned that we have some mistakes during the development process. As mentioned, for the over-the-air transfer, we use the portable device. But if the same implementation is used with the real LAN, the OTA transfer will fail, because on the real LAN, here I have the LAN diagram for that. On the right side is the device from the Silicon Labs, and on the right side is the RTS Solo device, actually. And on the RTS Solo, in the connecting to the device is straightforward, but on the Silicon Labs, we have just one step when connecting. We have just 20 seconds to read the secret key to the device. And if the secret key is not written to the device, then everything after that will fail, because the gates on the device are closed. Yes, here I want to mention that and emphasize that the adapting to the different flows after the hardware is available is required, and it's mandatory, because using the virtual devices can help in the development process, but when the real LAN is used, then maybe, as I mentioned, some flows are different. It's not the same on the virtual device. It's good to be used in the for the testing and confirming some of the features, but not for the end product, actually. And from that, I want to conclude that the working on the Android Bluetooth Low Energy without hardware is possible. It's not the maybe it's not the best approach. It's not the best way of doing the things, actually, but on the end of the day, it's possible. Maybe it will require some adaptations and refactoring of the code after the hardware is available, but that's it. That's it from my side.